Video lecture for ANP2, lecture test 1, video 3 for Del Mar College. And we were on Noteset page 6. We were just starting page 6 with the word olfaction. And, oh, timer. Let's start a timer or I will talk. Okay. So olfaction is smell. The olfactory organs are the two organs that smell. You have two of them, one in each nasal cavity. Each nostril leads to a nasal cavity. So you have a left nasal cavity and a right nasal cavity separated by the nasal septum. The bony nasal septum, as you know, is superior portion is the perpendicular plate of the ethmoid bone, and the inferior and posterior portion is the vomer. And then, of course, the anterior portion is cartilage. So that's the olfactory organs, one in each nasal cavity. The nasal cavities we just covered, and odorant is a smelly molecule, literally. Let's see, let's do a laser pointer. There we go, odorants. And the olfactory cortex is the portion of the brain that processes. Let's see, checking my old note set. Excellent. Yeah, all right. That's that page. Next. Okay. So in the olfactory epithelium is next on the note set. So the olfactory epithelium and the lamina propria are the two major parts of the olfactory organs. They are on the superior portions of each nasal cavity. The olfactory epithelium consists of olfactory sensory neurons and basal epithelial cells, which are stem cells. They used to be basal cells, now they're basal epithelial cells, so things change. And the lamina propria, the epithelium, of course, is the cellular layer that lines the inside of the cavity, specifically in the smelly part at the top. And the lamina propria is a connective tissue deep to that, in this case, superior. And the lamina propria consists of areolar CT, blood vessels, and the olfactory glands. And the olfactory glands make mucus, which is snot. So I had a friend in grade school who always said, when you go to kiss a girl and your nose is cold and runny, you may think it's funny, but it's snot. Because grade school. Yeah, that's why. And then the generator potential. Oh, this has like a star with like a shadow. Oh, that's cool. The generator potential is the depolarization of the neuron that makes action potential. So the generator potential generates action potentials. Now, in the previous picture that we saw, there was a receptor cell that made a receptor potential and then a synapse, and it put chemicals across the synapse to the sensory neuron. And then the sensory neuron made generator potentials that generated action potentials. But in smell, in olfaction, there's not a separate sensory receptor cell to make a receptor potential. So in smell, the sensory neuron directly makes the generator potential, which makes the action potentials. Okay. Next slide. Okay. Only water and lipid soluble molecules. So we're in the sentences under the box now, filling in the blank. Only water-soluble and lipid-soluble molecules can diffuse into the mucus and be smelled. There are between 10 million and 20 million olfactory receptors. And why do we have such emotional responses to some smells? Let's see, I have that written out on the filled-in note set. So let's get the whole thing. Only sensory information that goes directly to the cerebral cortex bypassing the thalamus. As you may recall from last semester, the thalamus is a sensory filter. and only allows a very small portion of sensation to go through to become perception. And smell does not go through the thalamus. The information is distributed to the limbic system and hypothalamus, which does memory and emotions. And so often when you smell something, it takes you back to your first memory of the first time you smelled it, and many of the first times you smelled things is in childhood. So that's why so many smells like apple pie take you back to childhood, because you were a kid the first time you, most likely a kid the first time you smelled apple pie. I should hope. If not, the world needs more apple pie. Okay. Why do dogs have a more sensitive sense of smell? The book specified a specific type of dog, but said it had 72 times more sensory receptors. No, not receptors, more 72 times more receptor surface area. So that's why. And what should you do if you smell mercaptan? Specifically, the previous editions of the book said beta mercaptan. So mercaptan is added in a very small amount to gases with no odor. So natural gas, propane, the gas that you buy at the pump for your car, these have no natural odors. And so mercaptan or beta mercaptan is added, according to federal guidelines, up to a certain part per million, so that when there are gas leaks, because gas is highly flammable, when there are gas leaks, we can smell it and know that there is danger. Okay. So what should you do if you smell mercaptan? Get out the house, call 911. Get out the house, get everybody out the house, call 911. Okay, so that's page 6. Now we're at page 7, which says it's for a spotlight figure. Oh, first though, is this on this note set? At the very bottom of page 6. Very bottom of page 6 in italics in a different color. It says on this picture, how does the swirling air help olfaction? So if you haven't done the lab videos yet, video, making a note on a post-it. Video 3, link. Actually, we're not doing this until digestion and respiratory. So yeah, no, we don't need to do that. Okay, so this is the superior, middle, and inferior nasal concha. The inferior nasal concha we learned about in lab. This is what it actually looks like in an IRL body. And the holes underneath them where the air swirls are the superior, middle, and inferior nasal concha. So you can see based on the spiral here that it will literally swirl the air around in your nasal cavity. And the function of these swirls is to get as much air as possible, as many odorant molecules as possible up here to the superior areas of the 2 nasal cavities where the olfactory organs are. So the olfactory organs include the olfactory epithelium and the lamina propria, and in the lamina propria, the olfactory glands. So up here. So that's why we swirl to get the odorant molecules to the olfactory receptor surface. First time my husband saw this picture, he's like, why? Why would they even? I saw this picture, I was like, ooh, that's cool. So that happens. All right, top of page, I already showed you this one. All right, this is where we are. Number 1, and we're going by the number on the picture here, number 1. An odorant molecule binds to its receptor protein. This activates adenylate cyclase. There's a difference between adenylate cyclase and adenylyl cyclase. I don't remember. It's not relevant to what we need to know. So we're going to pretend like adenylate and adenylyl are more or less interchangeable. They're not, but beyond the scope of this class. Same coffee. It's cold now. Different outfit, though. This is my third outfit of the day. Making up for lost time. Okay. I don't have like casual clothes wardrobe. I've really only spent clothes money on work wardrobe because I have to have a work wardrobe. So I just kind of wear work wardrobe as casual clothes, but that has not fit. So luckily, I have a small collection of printed t-shirts, mostly in science and sci-fi. So there you go. That's my not work wardrobe is science t-shirts. And, you know, Star Trek and Star Wars. So, ooh, and some Stranger Things. Oh, I have the ice cream shop t-shirt, and it's got like a list of flavors on the back. It's super cute. Okay. It's all about the sci-fi. I've been doing this for too long. Let's move on. An odorant molecule binds to the receptor protein. This activates adenylate or adenylyl cyclase. I don't remember which one does first, and then it turns into the other one. Beyond the scope of this class, either way. But we do need to know that that converts an ATP to a cyclic AMP, abbreviated little c, big A, big M, big P. Number 2. Boom. The cyclic AMP binds to a sodium channel. Sodium, as you know, is abbreviated Na+. Sodium. Okay. Sodium ion channel, which opens it. Okay. Opening it. Opening the sodium ion channel allows positively charged sodium ions to rush into the cell, which we already discussed in whiteboard segment, making the cytosol less negative, and that's called depolarization. And we already had that conversation in a previous video. If you did not know that off the top of your head, go watch it again. Oh man, if I were fancy, I think 2, and that would be the first video. I think maybe I can figure out how to make a card from here to that first video. No promises. I was going to do it on the second video, but it's still loading. Also, it's still light outside, so we're still recording. And my hair's caught in my earbud. Okay. Moving on. Number 3. If the cell depolarizes enough, it triggers an action potential in the axon. The generator potential continues to generate action potentials until the stimulus is removed. Okay, so that's all about smell, which is olfaction. Next is taste. Oh, we already said that. But here it is with a star, so that's important because I spent the time to like cut and paste a star. Okay, gustation. Here's a review of the whole thing. All right, we're not done. So, as a review, the odorant molecule, that's the smelly stuff, binds to the smelly stuff receptor, which activates the enzyme, which we're calling either adenylyl or adenylate cyclase. And that activated enzyme turns ATP into cyclic AMP. And of course, this is the cell membrane. This is the mucus outside the cell. This is the cytosol, the fluid inside the cell. So the cyclic AMP diffuses around inside the cell and binds to an internal intracellular receptor, which is a sodium ion channel. And then when the cyclic AMP binds to the inside of that receptor, it opens it. Sodium, like fools, rush in. depolarizing the cell because positive inside a negative makes it less negative. And that's how you smell stuff. Taste is called gustation. The gustatory epithelial cells. Okay. Front page. Gustatory epithelial cells? Is this a new term for the taste receptors? Gustatory receptors is what they used to be. Okay. They're on the tongue, parts of the larynx and pharynx, and in taste buds on the papilla. The papilla are the bumps on the tongue. So the gustatory cortex is the part of the brain that processes taste. Lingual papillae are the bumps on the tongue. There are 4 types of papillae. The previous version of the book only had 3. Now there are 4. The filiform papillae are thread-shaped and they do not have taste buds. Fili for thread and form means shaped form. Fungiform fungi. When my kids were younger, they're like 11 and 14 as I record this, and a half almost, both of them. And but when they were younger, this was one of their favorite jokes for several years. Why does a mushroom always get invited to all the parties? Because he's a fun guy. That's what it's like at my house. So the fungiform, mushroom-shaped papilla has a few taste buds, I believe about 5 each. The number 3 is the velate papillae. These used to be circumvallate papillae, and they have like up to 100 taste buds each lined up on the sides. And then the foliate papillae are the new ones, and they are the folds on the side of the tongue. Taste buds in the folds on the side of the tongue. And I don't have written down how many taste buds they have each, so there you go. And then the taste buds are the sensory structures on the papillae, 3,000 to 5,000 taste buds in an adult, more in kids, less as you get older. Okay, that was page 7. Did I start a timer? Oh, I did. Oh, and we're halfway through. Okay, moving on. Couldn't remember. Taste buds contain. Wait, first. Taste buds are located on the sides of the papillae recessed into the epithelium, as you can see here. So the food molecules have to be dissolved into your spit, into the liquids in your mouth, in order to get down into these recesses to be accessible to the taste buds. So maybe those. Okay, so taste buds are located on the sides of the papillae recessed into the epithelium. Each taste bud has 40 to 100 receptor cells and many basal epithelial cells. Again, they used to be basal cells. Stem cells. Each gustatory epithelial cells, those used to be gustatory cells, have microvilli called taste hairs. You see the cute little taste hairs sticking out of the taste pore. The taste pore is the hole that the taste hairs are sticking out of. And each typical gustatory cell lasts only about 10 days. This is where the Wood Noteset recommends that you eat chocolate often. Because if you don't eat chocolate every 10 days, you will have had taste buds that have never tasted chocolate. It's just not fair. Okay, so taste is innervated by 3 different cranial nerves. The facial nerve, cranial nerve 7, covers taste on the anterior 2/3 of the tongue. Glossopharyngeal 9 is the posterior third. And the vagus baby is a 10. And that covers the innervates, the epiglottis, taste buds on the epiglottis. Also, you have taste buds on your epiglottis. Now you know. And the pharynx. Okay, so why does food taste dull when you have a cold? You are 1,000 times more sensitive to taste when you can smell. So basically, most of your taste is actually smell. Your olfaction is much more sensitive than your gustation. So when you have a cold and you can't smell anything, that's what your food actually tastes like. So there you go. Next. Ooh, a quiz. Okay, name the 5 senses. So there's the kindergarten senses, all 5 senses. So we've got smell, taste, sight, hearing, and touch. Now, of those, one is a general sense, that's touch. And then there are 5, so that's great, takes you down to 4 in the screen. And there are 5 special senses. So the 5 special senses are sight, vision, smell, which is olfaction, taste, which is gustation, hearing, the technical term for hearing is hearing, and then also in your ear is equilibrium, which is the technical term for balance. Excuse me. More coffee. Getting kind of low, down to the dregs here. And that's where all the sweet is. Okay. Oh, and a lot of cinnamon too. Oh my. Okay. Depolarization in a sensory neuron is a sensation. Oh no, it's a generator potential, not the sensory or the receptor cell, but the sensory neuron. So it's a generator potential, and it generates action potentials. And a receptor cell can have a graded depolarization or a hyperpolarization. Okay, next. Boom. Gustation. Did we already talk about taste? Oh, that was a quiz. Okay, so for primary taste sensations, I maintain that the primary taste sensation sounds like a great name for like a 50s doo-wop band. Primary taste sensations. Feeling it? I think it's a great idea. Anyway, they are sweet, salty, sour, and bitter. You have the additional taste sensations of umami, which I believe is Japanese for deliciousness. And it's free glutamates, which are an amino acid found in broths and Parmesan. And then you also have water receptors in your pharynx, and they inform your water balance and blood volume, but you do not have perception of the water reception. So, also, okay. Also on the umami, you should know that they are mostly on the valate papillae, more of them on the valate papillae. And then the water, when you drink water, that reduces your ADH secretions. So let's talk about ADH real quick because it's very important for both test 2 for endocrine and also for the urinary chapter. Whiteboard. I did it. Okay. So pen. What color are we? Nope. Pen color. Let's go gray. I haven't done gray yet. It's too late at night. What was I here to talk about? Oh, 88. That has not nearly enough contrast. We're totally picking a different color now. Green. Ah, neon green. I hate neon. 88. That just got terrible quickly. Okay. A is for anti as in against. D is for diuretic. D-I-U-R-E-T-I-C. H is for hormone. O-N-E. Okay, antidiuretic hormone. So when you take a diuretic, it makes, I miss whiteboards. I miss walking into a room and talking to people. Makes you pee. There we go. So when you take a diuretic, it makes you pee. So anti means against. So the antidiuretic hormone makes you not pee. Urinate. So when you drink water, activates the water receptors. The water is tasted, the taste sensation, and that reduces, on screen, reduces your ADH secretions. Excuse me. So you make less antidiuretic hormone. So a diuretic makes you pee, antidiuretic makes you not pee, and drinking water inhibits antidiuretic hormone. So drinking water makes you not pee. Get it? So it's a double negative. So when you drink water, it makes you pee. That's all. Okay. And what is PTC? Are we going the wrong way? Where are we? Okay. What is PTC and what does it tell us about gustation? And we did the G versus with the EI or Y after it says J, and a G with an AOU or consonant says G. So gustation. Gestation is pregnancy. Remember G with an E after it says J, and a G with U after it says G, because phonics. Who knew? I didn't know. I was taught whole word because that was back in the day, and they didn't do phonics. They were anti-phonics at the time. And so I didn't know any of that until I taught my kids how to read. So, still off topic, aren't I? Ooh, marks. That's fun. PTC and gustation. PTC is phenylthiocarbamide. I will never, ever ask you to spell that. You're good. But it's a thing that some people can taste and some can't. You can buy the little strips and have people, and you can like chart out the genetics of how the many people in your family can or cannot taste the PTC, and maybe you can work out if it's dominant or recessive. Ooh, that would be fun. Okay. And what does it tell us about gustation is that taste is a very individual thing and it depends on your genetics. So how does tasting ability change with age? It decreases if you have a grandma that is making her food spicier and spicier and spicier. It's likely because her gustation is decreasing with age, and so she's making her food spicier so that she can taste it. I'm from the Midwest. Neither of my grandmas had ever tasted anything spicy, neither would they dare try. That's what the Midwest is like. Okay, salt and sour stimuli. How do you taste? We're on page 9. How are we at time? Oh, we have 20 seconds left. Okay. Well, that's like a whole page, so we're going to quit there. We're going to quit here. What page is that? 9. No, so we got 6 through 8. And then the alarm's about to go off. Stop, not repeat yet. Okay. All right. Yeah. Okay. So we did pages 6 through 8, and this has been a video lecture for AMP2, lecture test 1, video 3. And it's getting kind of late at night for me. I'm getting kind of distracted, but I think we have enough light to do one more video. We'll see. Okay. So thank you as always for tuning in. And COVID or not, the education must go on. The world needs nurses now more than ever. All the healthcare providers are so important in this time. We've found out who really is essential. So thank you. Dr. J out. Wait. I've got it. It's Command Control Escape. Oh, I had it. Okay, Command Control. Thank you.